Hello, everyone. Welcome back to Data Champions Online, the leading online event for senior data and analytics executives. We have a jam-packed week of presentations from some of America's leading data and analytics leaders. Before we kick off with today's sessions, I just wanted to run through some housekeeping. We will be stopping for a 10-minute Q&A at the end of each session, so please do submit your questions via the Q&A box on your webinar interface. If we don't have time to get to all the questions, we will try to respond to them by email after the session has ended. Without further ado, I'd like to introduce our next session, where we will be discussing machine learning and analytics in the cloud. We are joined by two excellent speakers from TIBCO today. First, we have Hillion, who has been leading large engineering and analytics projects for 20 years. He founded Alpine Data, acquired by TIBCO, to build a collaborative platform for data science. Before that, he led the global team of data scientists at Pivotal and developed a suite of open source and enterprise software in machine learning. Earlier, he led engineering at a series of successful startups. He received his PhD in mathematics from the University of California, Berkeley, and before that, read mathematics at Oxford University. We also have Vaibhav Gedigeri. Vaibhav is a key data scientist for the TIBCO data science team. Prior to joining TIBCO, he worked as a full-stack data scientist at Honeywell for 3 years, where he developed data science solutions at scale, spanning across aerospace and energy sector. His focus has been in making complex data science solutions more explainable to business end users. He received his master's in applied statistics and operations research, and before that, his bachelor's in computer science with a minor in artificial intelligence. Before I pass over, I just wanted to kick off with 2 quick polling questions to get some more information from the group. Our first poll is, how far along is your organization with applications of machine learning? We have many ML models in production. We are just starting to operationalize machine learning. We have data science teams that do machine learning, but nothing is operational yet, and we don't do much machine learning. I'll give you a few seconds to give us your best answer to that question. All right, let's take a look at some of the results. So it looks like the vast majority of you don't do much machine learning at all, 83.3%, and then 16.7% answered that you're just starting to operationalize machine learning. So hopefully there'll be a lot of valuable takeaways in this session for you. Now, one more poll before we get started. This question is the majority of your data science and machine learning done in the cloud or on-prem? Mostly in the cloud, mostly on-premise, a mixture of both, or not much of either? All right, let's see the results of this one. So it's a unanimous decision on this one. It looks like everyone is doing a mixture of both. So with that, I'll turn things over to Stephen, and we're looking forward to this session today.
Great, thank you very much, April, and it's a pleasure to be here. Vaibhav and I are going to talk today right about machine learning and analytics in the cloud. And actually, I'm kind of encouraged that there's a large number of people in the audience who really are just getting started on their journey towards machine learning and operational machine learning, because I think one of the advantages of using cloud technologies is that things just move faster and it's easier to get going. So if you really are just getting started in terms of applications of machine learning, I think looking towards the cloud as a source of technology and inspiration is it's not a bad way to start. So I want to begin the presentation with a walkthrough from a real-world example. Let me just share my screen so I can show you some of the work that we've been doing on the data science team here at TIBCO. So hopefully you can see my TIBCO data science workspace here. The project that we're working on in collaboration with one of TIBCO's customers is trying to identify anomalies in a power plant. We've anonymized the data here to protect the innocent, but this is a real project to do anomaly detection, trying to look at sensor data coming out of a power plant and identify if something's going wrong. And let me explain roughly what we did. There's this project here. This is running on Amazon Web Services, AWS. You can see from this workspace, this project overview here, there's a number of people from the TIBCO data science team who are working on it. Here you can see some of the work that we did, and central to this work was this visual workflow, and this is running on EMR. EMR is a big data source running on Amazon. I'll talk a little bit more about that later, but for now, just notice that this is running against data that is in an EMR Hadoop cluster in AWS. And if I open up here to see what work the team did, you'll notice it's actually fairly simple. We're taking sensor readings in here. Here's the timestamp from the sensor reading coming off the power plant. You see various measures of pressure and gas, differential pressures, and so on that are recorded in the sensor. We do some basic sort of data prep here. We're creating some different variables, time of day type variables, that sort of thing. We normalize the data. So you see here originally these measures of pressure and gas here in the 20s, single digits in the hundreds. When we normalize this, everything is sort of normalized between 0 and 1. Really easy to do. We're just saying, please transform these into a range between 0 and 1 and transform pretty much all of the variables in the data set. No coding required. And eventually what we do is we're going to pass this into a special algorithm. And the algorithm, without going into too much detail, is a deep learning algorithm. And what it does is it learns from historical data, and it tries to reproduce the world in a model. You might have heard of predictive models, right, that can predict something based on historical data. And here the historical data are these historical pressure readings. And what the model does is it takes in that historical data and tries to construct a model of the way the world works, and then to produce a prediction. And the prediction in this case isn't just a single variable, like is there an anomaly or not. We can't do that because actually we don't know what the anomalies are. This is what's called unsupervised learning, where we can't tell the model what to find because we don't have enough anomalies in the past to identify them. So we're asking the model instead to predict the original data, to actually reconstruct the original scenario, the original historical data from the model that it learned on that historical data. Now that seems a little bit like sort of swallowing your own tail. But what it's doing is it's saying construct a model that's simple, just a simple low dimension, sort of a low number of factors model of the way the world works, and then attempt to reconstruct reality using that simplified model. And the cool thing about that, and I'll explain later how we built this model, the cool thing about that is that by trying to produce a simple model of the world, anything that's not normal, anything that's sort of outside the realms of the normal behavior in this historical data, ends up not getting reconstructed very well. When the model tries to reproduce the past, anything that's unusual will stick out like a sore thumb. And in fact, we can measure that when we join the original data. So here's the original historical measures. And here we have the predicted things, and we can essentially just measure the distance between them. We call that reconstruction error. How different is the actual historical result from what the model predicted? And in some cases, what you'll do is you'll get mostly low reconstruction error, but if I sort, you'll see a few up here that have high reconstruction error. In other words, the predicted value is very different from the actual value, and that's a sign that it's anomalous. Well, look, we don't have to get into too much detail about the predictive models here. The bottom line here is I was able to reconstruct this using this fairly large data set that's sitting in the cloud and using this code from Amazon and from Google. If I click on this, I'm plugging all my data into this Python notebook. If I open up that notebook, here's the code. And essentially what this is doing is it's just plugging the data that I got into something called SageMaker, something called TensorFlow. SageMaker is the sort of control layer for doing machine learning that Amazon provides, and TensorFlow is a way of doing deep learning, these advanced, really clever algorithms that Google provides. And all I do is I just plug my sensor data into this algorithm, and it spits out a prediction at the end, the one that you saw me, and then I can continue using this in my flow. And what I can do with that then is that I can actually build a dashboard off it. Here in my project workspace, I have a dashboard that the team has built. The dashboard here shows me, if I look at the original time series, it shows me all of the sensor readings. Now, if you look at this, I don't know about you, but I wouldn't be able to tell if there's something anomalous going on here, right? I see a few spikes here, but there's lots of them, so any of them particularly special. I see a few unusual spikes here, but they don't necessarily seem to be happening at the same time as the other spikes in this data set. So, I really need to look at the whole thing. And that's exactly what my machine learning model did, what my anomaly detection did. And here's the instruction error that was produced by that workflow that I was just showing you. Here we're graphing it now back on a time series, and we can see very, very clearly that there's a few measurements around here that seem consistently erroneous, consistently abnormal. So if I highlight these now, this is using TIBCO Spotfire, our data exploration and visualization application. I can highlight these, and these will actually go back and they'll highlight the corresponding points in my time series. And you can absolutely see here, there are certain points that if you looked at, say, the furnish wouldn't look particularly unusual, but there's a consistent number of high readings from the burners, pressure coming off from the burners that is spiking at that one particular point. I wouldn't necessarily have known that that spike itself was important, but when you look at the whole data set and run it through these advanced models, it tells me where my anomaly is occurring. And what I can then do is that I can send that out to my team. I can assign them to the particular plant that needs to be looked at, and they can dig in and see if something really is going wrong. So why am I telling you this, right? What has this got to do with the cloud? Well, let me explain very easily. This whole project was run on Amazon. It was run through these simple visual workflows that were using a really powerful database or Hadoop cluster called EMR that is also provided by Amazon. And this machine learning model that I built in this Python notebook, in this Python code, was also all provided by Amazon through its SageMaker offering, and from Google through its TensorFlow open source project. In other words, my team was able to do something really difficult, which is to find mysterious hidden for a power plant from a huge quantity of data by just constructing a simple visual workflow using some out-of-the-box tools from the cloud providers, Amazon and Google, and then produce that in a dashboard that we could share with the client. So it gets back to my original point then, which is that by using cloud technologies, it can be much easier than you think to get started with machine learning. Okay, so let me take a step back a little bit. Let me return back to the slides here. And let's take a look at this slide, which sort of summarizes the cloud technologies that are available from Amazon, from Google, and also from Microsoft in order to run a machine learning project. The first thing is, what sort of machine learning tools do the cloud providers create? I mentioned a couple of them already. SageMaker is an out-of-the-box toolkit from Amazon that allows teams to work with a variety of different machine learning algorithms without doing a lot of extra work. Google has its equivalent, the Cloud AI platform. And I also mentioned TensorFlow, and Azure has its example. Azure is the cloud offering from Microsoft, and it has its own toolbox for machine learning called Azure Machine Learning. I mentioned TensorFlow as a sort of pre-built way of doing deep learning. Also, Google has pre-built models, AI building blocks. So if you want to do something like facial recognition, or if you want to do text analytics, if you want to identify fraud, there are these pre-built models that the cloud providers create. For Amazon, that's AI services. Google has AI building blocks, and Azure has cognitive services. And then finally, there are applications that you can use in the cloud. You just saw one, actually, TIBCO's data science platform. That's available on the ML marketplace from Amazon. Google similarly has its own set of its own marketplace for offering machine learning tools and applications. Microsoft also has the ML marketplace. So in terms of machine learning tools, there's really a breadth of offerings from Amazon, Google, and Microsoft. Some commercial, like TIBCO Data Science, some open source, like TensorFlow, and some completely pre-built, such as the facial recognition stuff. And Vaibhav, my colleague, will give you a demonstration of that at the end of today's presentation. So there's just a ton of rich functionality available, ready to go in the cloud that you can spin up right now. Remember when I was showing you my my demo, I said that my data was sitting in EMR. And in fact, when I was running my report, I pushed out the final results to the dashboard through a database called Redshift. So the cloud providers also provide these data sources as well that you can use to store and query data. Well, of course, we're all very familiar with standard enterprise databases like Teradata and Oracle. And more we're familiar with big data sources like Hadoop and Spark and Hive and so on. And the cloud providers provide their own sources for databases, both OLAP and OLTP. They have large parallel databases like BigQuery and Redshift and Azure SQL Data Warehouse, and smaller transactional databases like RDS from Amazon and Aurora, Cloud SQL and Cloud Spanner from Google, and your standard SQL database, essentially Microsoft SQL Server running in the cloud from Azure. They have streaming services. They have equivalents for Hadoop. I already mentioned EMR from Amazon, Dataproc from Google, HD Insights from Microsoft, and also ways of just storing your raw data. Highly scalable cloud storage solutions, S3 from Amazon, Google Cloud Storage, and Azure Data Lake Storage. So, you know, when I was preparing for this presentation, it was hard to pick the technologies to go through, because what I'm showing you on this slide is just a small subset of the sort of data and analytics and machine learning services that the cloud providers have created and that are available right now on these cloud services. But what I think is on this slide is a good representation of what you would use for empowering a data science team with tools that they can run really quite easily in the cloud. Machine learning tools at the top there, data sources, both relational and streaming and big data, and then storage solutions. And so that's sort of my overview of where you would go shopping, if you like, if you wanted to buy a rich set of tools for your data science teams. And as I sort of implied with my first demo, you can set these things up pretty quickly. You can purchase commercial tools, you can get them running against these data sources, you can upload your data, and you can really start building these pretty sophisticated projects in just a matter of days. Here's some examples, a couple of other real-world examples that I want to talk through where we've leveraged these machine learning tools in the cloud to do some really exciting work. Tipping Point is a charity, a not-for-profit, a grant aggregator here in San Francisco, and they're dedicated to fighting poverty and homelessness in the city. A fairly new charity, and they've been doing just some really great work. And we've been helping them with some work that my data science team has been collaborating on. And what we did is we looked at various traffic and parking data in San Francisco and identified ways that it had a disproportionate impact against low-income drivers. Even before taking into account their income, they were higher fees generally, and then as a proportion of income, just sort of monstrously high. And so we actually presented this in a series of analyses that we did for the San Francisco city government, which were produced in exactly the same way that I just showed you. We set up data sources on Amazon, loaded that with over 5 million parking citations, as well as corresponding financial data and transactions and towing data. We analyzed this in these visual workflows running against the Amazon data source. We used some of those open source libraries. We eventually published the results through these dashboards. We presented these findings about the high impact on low-income drivers to the city, and there was a resulting change in policy, which was instituted last year, and we're very proud of that. We think it's just made the whole system a lot fairer. And really, I think the main thing I'd want to highlight from that project is that we were able to get it up and running in just a few days by working with Amazon. And my team collaborated with the data science team at Tipping Point. This really was a shared project. And because we're all doing it in the cloud, we can all log into the same central location. We can all share our data, but also make sure that it's protected when necessary. It makes it really easy to collaborate through a central set of resources and using a set of technologies that we were all familiar with. So I think that's one advantage of doing a cloud-based project like this. Here's another example where we can actually have a really flexible solution. One of TIBCO's clients is Leidos, formerly part of Lockheed Martin. They do government contracts, working mostly with healthcare organizations, organizations like CDC, National Institutes of Health, Medicare and Medicaid, also some of the healthcare aspects of the work of long-term spaceflight that is done by NASA. And so using the same platform that I've just been showing you, the TIBCO Data Science platform running on Amazon, Leidos is able to react to a large number of very ad hoc investigative projects from the government. So they were able to spin up one of these instances and look into disease outbreaks, outbreaks of HIV caused by the opioid epidemic and also Zika outbreaks. With CMS, we're looking at healthcare policies and enforcing quality of healthcare across Medicare and Medicaid. And with NASA, we were able to do text analytics to understand the impact of long-term spaceflight on the health of astronauts. All of this was done essentially by spinning up systems in a matter of hours, loading the data and performing these advanced analytics using tools very similar to ones that I showed you, these visual, simple, low-code workflows, as well as some of these open source libraries. And so what you have here then is this ability to react quickly to projects. And the nature of data science projects often is that they're not like software engineering projects. They're not necessarily governed by a central specification, which remains largely unchanged through the project, and you just react to that through agile processes and then deliver something at the end of 6 months that goes through a standard software development lifecycle. Often with a data science project, you don't even know what the data contains when you start. You're not even sure what the end goal is. It's often very exploratory in nature. And so having a flexible and dynamic and scalable and elastic cloud-based solution allows you to spin up new data sources for dealing with structured and unstructured data, and to leverage different tools as you see fit as the nature of the project changes. So this degree of flexibility has been really key with Leidos, and you can find some articles about Leidos' work on the TIBCO website if you want to dig into any of these use cases. They're fascinating just by themselves. I've mostly focused on the technologies that the cloud providers have delivered here. I've mentioned the machine learning tools and the data sources and the storage and the open source solutions. As I mentioned, though, each of the cloud providers has a marketplace where you can spin up solutions from companies like TIBCO that provide you with something like a data science platform. In the case of TIBCO, it is the TIBCO data science platform. It provides the sort of interfaces that I was showing you in my demo, so you can have connected teams collaborate together. These may be data science teams scattered around the globe within different departments between one enterprise and their partners. So this degree of collaboration through a web-based interface. Because we are able to leverage these big data solutions like Redshift and EMR from Amazon, or HD Insights and Azure SQL Data Warehouse from Microsoft, and so on, it means that our algorithms that we provide through this simple drag and drop interface are not only easy to use and don't require a lot of code, they're also really, really scalable and powerful. So you have the power of machine learning, and you have the scalability of these cloud-based data sources, but through this simple web-based drag and drop interface. And the whole platform was built in some sense for the cloud. It's built to be web-based and lightweight and to leverage the type of data sources and open source solutions that you can provide, that you can find with the cloud providers. So that's the TIBCO data science platform. That also includes the sort of dashboards and visual exploration that I was showing you before. So this visual dashboarding and analytics capabilities through the TIBCO Spotfire solution is also part of that, is also integrated into that platform, also available on the cloud. So just do a quick pitch there. I will say right now you can actually go to the AWS Marketplace and you can sign up for a preview of the TIBCO data science platform, connect to those sources of data from Amazon, and start building machine learning models. So I hope I've convinced you that two sort of conflicting ideas here. Not only do you have the breadth and the variety of solutions that the cloud providers have created, but you have that coupled with the sort of ease of use from a data science platform like TIBCO's, and the ability that cloud gives you to spin up environments very, very quickly without a great deal of IT overhead. And so this combination of power and scalability coupled with ease of use of flexibility is, I think, the central message of the cloud when it comes to doing analytics. And as I say, with analytics projects that can be very unpredictable in the beginning and that can veer off in different different but interesting tangents as the project progresses. I think the cloud is fast becoming the way to do machine learning and analytics. And we've seen over the last few years a real shift from heavyweight on-premise installations of our data science platform going against these big data sources, which can be really great from a point of view of security. They can be really great in terms of being able to access all of your enterprise data. We are nevertheless seeing a shift to the more lightweight approach that the cloud offers, and that I've tried to indicate here. Okay, so just to finish off now, what I'd like to do is to ask Vaibhav, also on the TIBCO data science team, to give another example, slightly different approach here of how the cloud can help. Here the focus being on being able to use pre-built models to do some really cool stuff. So Vaibhav, over to you.
Thank you so much, Stephen. Start to begin my screen share. And if I can just get someone from the call, they can confirm that they can see my screen.
I think we're getting there. And yeah, looks like we can see it.
All right, perfect. Thank you so much, Stephen. Thank you for the introduction and a detailed overview of our stack. So today's demo is kind of, we're going to be kind of tracking a customer's journey, and we're looking at an Airbnb reviews data, and this is open source from inside Airbnb.com. And we'll basically be looking at how we can track a customer's journey all the way from booking till the experience itself. And we will be using TIBCO Spotfire to kind of visualize and even call some of the services from Google Cloud Platform to analyze the review data. All right, so let's kind of start off with what we are looking at here. So on this here, you can see on the right-hand side is kind of just a snapshot of what the Airbnb review data looks like. So we typically have about roughly about 22,800 reviews here. And these reviews basically contain all information regarding hosts, their listings, what type of listings they have on there, the price of the listing, and so on. So they also have the lat and long, which is why on the left-hand side, if you can see the map chart, just kind of displaying the density by price of how the Airbnb listings look like in New York, in the New York area. So just a quick look, you can see that the uptown area of New York City is slightly a little bit more expensive than the Upper East. So moving on. So here, there are a few things happening here. And first of all, I'd like to start off by saying what this data is, what data are we using, and where is this data actually stored? So the Airbnb reviews data that we saw previously, now this is being stored in Google BigQuery. And BigQuery is nothing but the enterprise data warehouse solution for Google Cloud. And we are kind of uploading the data set there, and we will be using it to connect it to Spotfire. And Spotfire has a direct connector to BigQuery. So you just log in with your Google credentials, and you have access to the data. So two things happening here. So on the top left, you do see that there is something, there is a kind of a limiter on the rows. And since we have about 23,000 rows, just for the sake of this demo, I have kind of decided to just look at the first 1,000 for the sake of simplicity. So the two things that happen here on the left-hand side is first using the Google's AutoML service. And what the Google AutoML service really requires a user is to upload a data set and corresponding labels. Now, what do I mean by labels? So here, these labels that you see here, the 8 labels that we have generated, these are kind of user defined. And if you think of it in terms of someone at Airbnb, maybe the marketing team or the support team, and this is a very domain knowledge based approach where you can just kind of decide to use certain labels where you can put all your reviews into. And why do we need this? The first question is, why do you really need to classify your reviews into labels? Now, this will really help maybe an analyst in the support team kind of zero down onto which areas or which type of reviews should they be focusing on. Are if a lot of the reviews that are concerning to maybe hosts, there are some issues with the hosts, so we can actually kind of zero down on that. So this is the AutoML service that's provided by Google, and all of this is done as a batch. So this is the custom model, and Google only requires you to upload the data set, which contains the text and the corresponding labels, and basically it will kind of label the data for you. So this is a classification problem. Now, if the question is, how's the performance of this model, it kind of really depends on your use case to use case. But in this case, we have a pretty good degree of classification. Right on the right below that is we can just see a little visualization where this is kind of we're looking at breaking the reviews down by neighborhood and the categories by the row count. So a quick look at some of them. You can see that Brooklyn, we see quite a lot of reviews that were in Brooklyn that were concerning to hosts. And similarly for Manhattan, we also had the same thing. And for Harlem, it was a lot related to the decor of the listings. Now, on the right-hand side is where we start our first stage of analysis, which is the sentiment analysis. So sentiment analysis is kind of just looking at the reviews and trying to understand the sentiment towards the review. Is this positive? Is this negative? How positive is it, or how negative is it? Now, what we are kind of displaying here is kind of a KPI chart. So the blue indicates a positive sentiment and the red indicates a negative sentiment. So if you kind of look at, in the first one in Middle Village, the sentiment score is actually pretty good, and it's 0.90. And a lot of the reviews were kind of corresponding to the neighborhood. So one could guess that there are a lot of things to do around a lot of these listings here. On the other side, if you look at it, for example, for Brooklyn Heights, we see this has a very negative sentiment to it. And we could see like a lot of reviewers have some negative sentiment or some complaints regarding the hosts in that area. So as an Airbnb analyst, this would kind of help them to zero down and look at these listings in these neighborhoods and kind of reach out to the hosts to kind of make sure that they're complying with the rules that are set by Airbnb. Now, one thing to note here is that everything here is done as a batch scoring. Now, drilling down further, we will now be looking at how do we do online scoring. And I'll get to this, quite a bit is happening on this side too. And so on the top left, we can see a kind of a little text box where there are reviews on here. And on the bottom, we see the classification probabilities. So if you remember from our last, sheet that I showed, that we would be kind of classifying the data into certain labels. So this kind of just tells you the probability of the review in a certain label. So let's say if I click on one review right now. So as you can see, there's something happening. So what is happening when I click on a review? So when I click on this review, on the back end, the Google Cloud Platform services is being called, and now you get a live score. So we can see that this specific review can be categorized into location and just as an overall, and a little bit of the host as well. So this is basically a live scoring platform, which we can achieve through Spotfire 2. Now, if we would like to further drill down into specific reviews, and which is something called as an entity analysis, which is also provided by the Google's natural language processing API platform. Now, what it does is on the top left, you can see that for this specific review, there is a sentiment score of 0.6 and a sentiment magnitude of 3.3. So what is a sentiment magnitude? Sentiment magnitude, the best way to define sentiment magnitude is, let's say if you have a review which has, if you have 3 different reviews, right? If one review has the word good in it, the second review has the word great in it, and the third review has the word perfect in it. So what the magnitude basically does is the review containing the word perfect is going to be given a higher magnitude or a higher number as opposed to the review containing the word good. So there isn't really a score or a scale for magnitude. Higher the number, better the sentiment. And for sentiment score, the sentiment can range from -1 to 1. So minus being on the negative side, +1 being the more positive end. On the top right, what is happening is we are taking the first step towards entity analysis. So what it does is it breaks this review down into sentences. And for each of the sentences now, you're going to see a score associated with it, a sentiment score and a magnitude. Now, sometimes why this would be helpful, and why would this be helpful? Consider reviews that are very long. And if the analyst would just like to understand how the reviews are written, do the negative sentiments come out first, or do people write complaints first, followed by some positive aspects, or vice versa? That would be good. That would be something good for them to know. If you drill one level down, and this is where there are a few NLP techniques being used, you can see that this review is now further broken down into vocabularies. Now, what is happening here is that from the NLP API, it is using techniques such as stemming and lemmatization. And what they do really is, considering a review, they are going to get rid of something called as stop words, words that appear very frequently in a document corpus, but don't really add a lot of value. So it kind of strips through all of that, and what we are left with is some vocabulary. And we do, again, have the magnitude, score, and the salience value. Salience value is also something that is related to magnitude. So the higher the score of salience, the better it is. Or if it's a negative review, the higher the score for the salience, the worse the review gets. So, and on the right-hand side, you see the KPI chart. Now, what it's doing here is kind of automatically tagging these vocabularies into the categories that we have defined. So you can see some of them, it gets pretty accurate. Like, for example, apartment comes under location. Cousin is as a person, drinks as a consumer good. Now, if you look at the color scale, you can see that apartment here is in blue, meaning it's a positive sentiment. Now, if you look at the review, the preceding word to apartment was great. And we can see that is why it has a positive sentiment associated with it. But this is not exactly true all the time, because sometimes some of these results don't actually kind of add up. As you can look at cousin, which is being classified under person, is as a positive sentiment, but it still kind of doesn't add up to why it is positive. So you might get certain results that don't make sense. But the overall idea being is, if you really want to break down or get down into a review, try to understand how these reviews are kind of structured, that would be very, very helpful. Moving on to the second part of this analysis is where we are kind of using JavaScript to generate something called as a word cloud. Now, these word cloud kind of just gives you an overall idea of how the entire document corpus looks like. So just looking at this, you can see that these entire reviews, we see a lot of occurrence of something like great location, places to stay, highly recommend. And on the top left-hand side, we kind of have added a filter where you can kind of break this down if you want to look at just an n-grams by bigrams or trigrams. Bigrams meaning great location, and you can change this to 3. And now you can see, wait for this to run a little while. Okay, so now you can see that these are some trigrams, but for the sake of these analysis, we're gonna kind of stick to just bigrams. And the word frequency is basically the number of words that you would want to see as an occurrence in the review in order for it to be considered in the word cloud. And this word cloud is kind of made in JavaScript. So it's a very simple thing. And you can look at it in terms of, we do have a feature called as a JavaScript visualization. And what we have done here is kind of just taken the source code from d3.js to create this word cloud. Moving on to the last aspect of this, which is the word-to-vec. Now, word-to-vec is nothing but a neural network, and it's an algorithm that kind of consists of two techniques, which is called as the continuous bag of words, as well as the skipgrams technique. Now, what is word-to-vec? And how is this important for us? So word-to-vec basically is just a representation of your n-grams into a vector space. Now, when there is a neural network, neural networks can't simply take in plain string as the input, so they do need vector representations, and which is what happens here. So why would you want to do this? The reason you would want to do this is kind of to understand which of the n-grams or which of these the vocabs that we had identified can be clustered together. So let's take an example here. For example, these three seem to be close together. So when we look at this, so we see three things here. One is reservation days, canceled reservation, Central Park. As an analyst working at Airbnb, this would be a very helpful information because now we can see that there were kind of reservation issues around Central Park. And this would kind of help the analyst zero down and maybe reach out to the listings which are around Central Park and kind of reach out to the hosts to see how they can resolve this issue. And this is one of the reasons.
Let's make sure we have time to answer questions. So if you can just wrap up quickly.
Sure.
I'm using some questions. I want to make sure we have time for them.
Absolutely. So this is kind of the end of this analysis, and this is kind of one of the ways how you can use Spotfire with Google Cloud Platform Services to analyze review data. So thank you so much.
Cool. Thanks, Vaibhav. What I think is really remarkable about this, I hope it comes out in the demo, right, and from the other demo as well, but especially this one, is that you can do this sort of sentiment analysis, right? So, you know, the tweets that people are writing about your organization, or your support calls, positive or negative, are people angry, happy? How did that product launch go? You can do this essentially for free using these sources that the cloud providers create. I mean, it's not literally free, but I mean, it's very easy to get this stuff up and running, and using these pre-built models is a great way to get started doing some pretty sophisticated stuff. So I hope that comes out. April, I think back to you, and let's see if we have any questions.
Yeah, we did have a few questions come in. We do have time for some of them. Obviously, anything we don't get to, we can answer via email. The first question is, how do you avoid getting locked into one particular cloud vendor?
Yeah, that's a good question, because some of the technologies that we've mentioned, you know, some of those data sources, for example, that you can use are certainly specific from one cloud vendor to the next. And obviously the cloud vendors, you know, in some senses have been really great in providing these open frameworks for machine learning, and very generous in that sense in terms of providing access to a whole host of open source libraries. But in the end, they want to drive you to use their platforms, as they naturally would. So the locking can be an issue. I think that if this doesn't sound a little simplistic, one thing you can do is try to find platforms that are layers of technology that are built on top of the cloud solutions. So there are lots of analytics solutions out there, some of them open source, some of them proprietary, like the TIBCO data science platform, that can connect to BigQuery, but can also connect to Redshift. They connect to EMR, can connect to HD Insights. They can work with SageMaker, but they can also work with TensorFlow, and so on. So they provide sort of an abstraction layer, if you like. It's also true that a lot of the technologies that you see here are open source technologies. And so in that sense, that's one way of, in a sense, avoiding vendor lock-in. And also some of the underlying cloud, data platforms are just standard relational databases. And therefore, if you're good about sort of keeping to Python and SQL, as well as agnostic platforms, then you should be okay.
Okay, great. Well, really, really appreciate you sharing this with us. One more question very quickly, and then we'll wrap up.
Yeah.
Do you think most machine learning will eventually be done with these pre-built models, or will there always be a need for custom models?
That's a really interesting question. What Vaibhav showed you here is a case where you really don't have to do any data science. You just send your text over and you get a score back saying this is happy or it's sad. And it's very tempting to believe that those will be able to meet the general demands of data science in the modern enterprise. And I think that's not true, however. I think it is always going to be the case that you as a company are going to have your own particular data, your own particular problems and challenges, and you will need to do ad hoc analysis. It's the reason why still most major organizations have software engineers and IT departments. You'd love to think that everything can be done with off-the-shelf software, but we all know that's not the case. At the very least, you need to integrate those software applications together. And it's just the same with data science. There's lots of great off-the-shelf technologies. There's great platforms. The one you've seen here, I think, is a very comprehensive platform. There's also all of these open source solutions, but somebody needs to knit those together. And I think in many cases, the type of data science investigations you want to do can't be solved just by a pre-built model, but requires custom models that take into account your particular data and variables. But certainly, I think that there will be an ever richer resource of technologies and models that can be used as a starting point.
Great. Well, thank you so much to both of you for joining us today. All of you in the audience, you will receive a link to the slides following the close of the full Data Champions Online event so you can revisit what you saw today. Our next session will be Building Your Data Dream Team, Recruiting and Retaining to Overcome Skill Shortage, presented by Ursula Catone of Huntington National Bank, and that will be coming up in about 15 minutes, so please stay tuned. Thank you.